Today let's have a look at different keypads you may want to use with your Arduino project. Here I have 4 keypads operating on the same principle, and let's start with most common keypad, which comes with LCD shield. This was one of my first Arduino projects. It is definitely very small and does the job. You can see here it has 5 buttons, the directional buttons and button select. I was really impressed, especially when I looked at the schematics and learned that only one analog port is used. Let's have a look at the schematics. This part, this voltage divider, is what actually delivers the keypad functionality. You can see that all these buttons, 1, 2, 3, 4, 5, select and 4 directional buttons, are used with the dividing resistors, and depending on which button is pressed, different voltage is delivered to the analog input of Arduino. So keypad takes ground, take VCC, the voltage of your controller, and produces the analog output, which depends on which key is pressed. Very smart, very simple solution, except that from the very beginning you can notice that if one button is pressed, for instance, if this button right is pressed, AD0 will go to ground, and even any other button is pressed, that will not change anything. So the principle of this keypad is such that only one button press will be recognized at a time. There are other keypad implementations which rely on the same principle. So this one, for instance, has 3 by 4 buttons, and depending on which button is pressed, the analog output produces this specific numerical value. There is this keypad operating in exactly the same principles. So let's have a look at how one may use this keypad. Right here, simple keypad is the test sketch. The keypad CPP and keypad H are the libraries that I created. You can see that in the setup, only a serial connection is established. And in the loop, all I do get is call function get and dispatch on the object, which is global keypad right here. My keypad is the global object that I create here, and I connect the keypad to analog input 0. And here's the small class that I defined, and I need to define this class in order for my functions to be called. So all these functions, on key down, on long key down, and on key up, are my callbacks that the library calls. Let's compile, download this sketch into Arduino and see how it works. So here I have simple Arduino Nano connected with 3 wires, 1 wire for ground, 1 wire for 5 volts, and another one for analog output. I press one button. Let's have a look at what I will get. On key down, on long key down, and on key up. And I can clearly see that there is some bouncing. On key down, on long key down, I press really hard, on key up. Key down, key up. Let's use a different button. On key down, on key up, on key down, on key up, on key down. And if I press key for a long time, I get on long key down. Let's now try to press 2 buttons. One button and then another. And you can see that the second button really doesn't matter, only the first that is important. So you can see that this approach works really well. It's pretty efficient. Only one analog input is used. However, I would like maybe to improve on the design of this keypad so that more than one button can be pressed at a time. Also, I find that this directional arrangement takes quite a lot of real estate, and I'm wondering whether this can be improved. Here is keypad of my own design. It borrows a lot from the design of regular, most simple Arduino analog keypad. First of all, instead of using all these 1, 2, 3, 4, 5 keys, I'm using a 5-way joystick. So in essence, it's the same set of buttons joined into one assembly right here. I can press on it, and this is similar to this button, and then I can tilt joystick in different directions. And of course I can tilt in more than one direction at a time, up and to the right, up and to the left. This keypad also has 2 extra buttons. So in essence, this is 7 buttons in a small package, and it uses very simple set of passive components to do the same voltage divider. The difference is also in the fact that 2 analog channels as opposed to 1 as here are used. So we will be able to recognize more than 1 button press at a time. Let's now connect this keypad to Arduino. It is connected as before to the controller using power supply and the ground, but it also requires connection to 2 analog ports in order for more than 1 button press to be detected. Here is my simple sketch, just 1 page. I include the definition for the library. I define my own class in order to have callbacks defined. Here I defined 3 callbacks on key down, on key up, and on long key down. And all I do in those callbacks is just print some message. I define the global object, my keypad, and I state the fact that this keypad is connected to analog ports 0 and 1. In the setup, I just establish serial communication, and in the loop, I call a single function. Within this function, the keyboard processing will be done, and one of those callbacks will be called. The sketch is uploaded. Let's have a look at the monitor. So I press and release just 1 button, on key down, on key up, as expected. I do the same for another button. So those are called soft A, soft B. Let's have a look at what will happen if I press 1, then press another, and then release both. Press 1, press another, and you see I get the message that 2 buttons are pressed. I get the message that the long key is pressed, and then I release both. And you can see that I get key up messages for both buttons. And as an argument, I guess the bit mask of the buttons that I pressed. One more time. 1, another, buttons together. Now let's do the same with the directional buttons of this joystick. Up, release, down, release. Now I will press up and to the right. Up and to the right. And you can see that 2 button presses are detected. Up and to the left, down and to the left, down and to the right. So this little piece of equipment is still easy to use, but pretty much allows you to do lots of fun stuff. Hope you enjoyed.